Hello everyone, I'm Raghuram and welcome back to the Data Engineering with Databricks series. If you are just joined, don't forget to check out the first video for an overview of Databricks. So in this video, we are diving deep into the concept of Delta Lake tables. So what is a Delta Lake? A Delta Lake is an open source storage layer designed to run on top of an existing data lake, and it improves reliability, security and performance. Delta Lake support asset transaction, scalable metadata, unified streaming and batch data processing. So in this video, we are going to cover on creating a Delta Lake table, inserting data into the Delta Lake table and querying a Delta Lake table. And we will be updating few records in the table, then deleting the records. Then we will create a CDC table, and using that we will try to merge the data into the main Delta Lake table, and we will examine the table details like the metadata, uh, and where it is actually stored, the files where it is present. So we will examine it, then we will explore those files for a Delta Lake table. Then we will review the transaction, like we will review the versions of a Delta Lake table. Then if we accidentally drop any table, sorry, not drop, if we accidentally delete the entire records from a table, and how we will be able to roll back to the previous version. So then finally we will just drop the table. So I am in my Databricks community account, and here I have created a folder called Data Engineering with Databricks, and a subfolder which is Delta Lake. So in this folder, I'm going to create a notebook. So before that, let me select an active cluster. Then also I will set the default language for this notebook to SQL. So let's try to create a table in Delta Lake. So whenever we create a table in Databricks, it will be considered it as a Delta table. So create table. So I'm going to create a table called students, and so before that, let me make sure there is no table with this name. So I will say drop table students. Yep, cool. Okay, so what I will do is I will create, like I will include three columns in it. So one will be ID, which will be an integer data type, then name, which will be a string, then finally class, and it will be an integer. So let me create the table students. Yep, so the table got created. One thing here we want to note is, so when we try to again execute this same statement, create table statement, so it will throw error because the table already got created. So to avoid this, what we can do is we can add one more condition, like command here, that is create table if not exist. So what it will do is it will execute the statement, and it will create table only if the table is not there. For example, students table is already there, so it won't again go and recreate the table. So for example, if I say students 1, then it will go and create a table called students 1. But again, if I execute students 1, it won't give any, like it will say okay, but it won't recreate the table students 1. Cool. So now let me try to insert few records into the table. So, uh, so it will be like inserting data and deleting data, or updating data. So it will be same as SQL, comparing to this Delta Lake. So insert into students, then values. So I will say 101, then yeah. So class will be 12. Let me put this in a separate row. Yep. So I will say 102, and it will be BBB and class 12. Then 103, which will be C and class 12. So we have inserted we are trying to insert three new records, and also I will add two more records. which will be 111, and some ABC, ABCD, and the class will be 11, and I will also insert 121 and some name, and class will be 11. So let me try to insert all these records into the table students. So we have successfully inserted 5 records into the table. So let's verify that. Select star from students. So we were able to see all the records that we have inserted into the table. So now what we will do is we will try to update a record in the table. So I will go and update 103 and then name for this 103 record. So update uh, update table, update students, set name equal to so let's give it as something like EE, and where ID equal to 103. So we have updated one record. So let's verify the record. Seeing select. So okay, so we have the select statement above. So okay, yeah. So we have updated it, CCC to EE for 103. Now what we will do is we will try to delete a record. So delete from students where, so we will delete this fourth record, which is 111. The ID is 111. So where ID equal to 111. So this will just delete the 111 record from the table. So let's verify that. Students, and we don't have that 111 record here, so we only have 4 records. So now what we will do is we will try to create a CDC view, and the CDC view will have a insert, a delete, and then update. So let me create a view. So create view, and the view name will be UPD underscore student, and so we will insert like we will create columns like ID, name, then class. I also add one more column which will be act as an indicator. So I will say UPD. So what this UPD will have is, it will have 3 type of values. One will be I, one will be D, and one will be U. So I stands for insert, and U for update, and D for delete. Um, so let me insert values into this. So what we will do is we will insert 2 new records. So we will say 104 DDD, and so the class will be 12. Then we will insert one more, it will be 105. Then it will be FFF, and the class will be 12. Okay, so I forgot to add the indicator. So here, so these two are insert, like it will be a new record. So the indicator will be I for these 2 records. Yeah. So now what we will add is we will add a delete. So we will delete this 121 ID row. So 121, and it will be an empty, and we will say null, and the indicator will be D, because we are going to delete this 121 ID. Now we will add an upsert as well. So we will try to update this 103. So 103, and it will be C. The name will be C, and the class will be again 12. Uh, then yes, so the class will be 12, and it will be an update. So we will say U. So let me try to execute this. Um, okay. 5 columns. 1, 2, 3, 4. Okay, sorry, I have added 11. Okay, cool. Let's try to execute that. Yeah, so the view got created. Let's try to verify the view. So let's start from view, and we were able to see the CDC. So using this update indicator, we will write a merge statement and merge these CDC records into the students table. So let's try to create the query for merge statement. So it will be merge into students, and I will add a alias ss using using the view that we created earlier. Like using this view, we are going to merge the records. So UPD student, and I will give an alias as U, and we want to say on what basis we are going to merge the data. So on so here, if you see, we have this ID which will be acting as a primary key. So using this ID, we also have this ID in students table as well. So using this ID, we will do the merge operation. So on s dot id equal to u dot id. So when this ID matches, so when matched, so what we want to do is first, so when it is matching, then there will be two situations. So one will be either it will be an update or it will be a delete. So I have this indicator, so I will add one more condition here, and so u dot upd should be u. So when the records, when these IDs are matching and when the UPD is u, in that case it is an update. So what we want to do is we want to just update the records. So you then update set star. So what this will do is it will just update that particular record with the value from UPD student. So then we will write another statement for delete. So when matched, and u dot upd equal to delete. So when the indicator is delete d, and when the record matches, then it will be a delete. So we will say then delete. So now what the remaining one is insert. So what we will say is when not matched. So when the IDs are not matching, then obviously it will be a new record in the students table. So we will just go and insert those records. So when not matched, and we will also make sure the indicator is I. So u dot upd should be I. So when the UPD is I and when the IDs are not matching, then we will just say then insert star. So this is how we want to write the merge statement. So merge into students, and using which table or view we are going to do the merge operation. And then on what basis we are going to merge. Then when matched, then what we want to do. Then when not matched, then what we want to do. So let me try to execute this merge statement. Yeah, so the merge statement got executed. So you can see that four new records got affected, sorry, four records got affected in the students table, and one record is an update and one is a delete, and there are two new records which got inserted. So let's try to query the table and see how it looks like. Yeah, so we have 101. So for these two, there is no change. For 104, we try to change the name. Also, we inserted 104 and 105, and we try to update the 103 record to CCC. And also, we deleted the class which has 11. So we deleted that particular record, and we did two insert and one update. So now what we will do is we will try to see the metadata for the students table. So to see the metadata, I will say describe students. So what this describe students will give us, it will give the column like the column names and the respective data types. We have few more advanced features in describe, like describe extended. So what this will give us, it will give more information about the data, like the metadata information, like uh, when the table got created, and where the table is located and what type of table it is, and whether it is a delta table or some normal table. So we will be able to see all these metadata from this extended command. So we also have something called uh, describe detail. So what this will do is it will even give some more advanced options, like uh, we will have this ID for the table. Then we will have this number of files. So whenever we create a delta table, when we query it, we will be able to see it as a table. But in the backend, what Databricks is doing is it is creating a Parquet file. So whenever we make a transaction, so when I say transaction, let's say whenever we do some operation like insert, delete, or update, or some whatever operation we do, Databricks will create a separate Parquet file for each operation. So that is considered as a transaction. So whenever we make a transaction, Databricks will create different files, and also it will create a log. So using that log, when we try to preview the data from a table, so using that log, it will get the data from the latest version. So when we say describe detailed students, it will show how many files combination will make the latest file. So we have four different Parquet file which will make the students table. So what now we are going to do is we are going to see the files, like the Parquet files from the for this particular students table. So let me try just copy this path. In Python, we have a Databricks inbuilt statement, that is db utils dot fs dot ls, and when we pass the path, so it will show the files and folders located in this particular path. So what I'm going to do is I'm going to use the display function to view this in tabular format. So we have path and names. So you can see we have these many Parquet files. So whenever we make a transaction, it will create a different Parquet file. So if you see, we have 1, 2, 3, 4, 5, 6, 7. So totally there are 7 Parquet file for this particular students table. But when we viewed this describe students command, we were able to see that it has only 4 files. So what does that mean is the current version of the table has only 4. So so it will make combine all those 4 file, and it will create this current version of the table. So this is the Parquet file, and we have a folder called delta log. So what this delta log will have is, it will have the JSON file, and that JSON file will have the metadata. So let's try to view those file as well. So now we are viewing into this delta log folder. So it has multiple JSON file. So what this JSON file will have is, this JSON file will have which all uh, combination of file will make the current version. So whenever we make a transaction, so it will create different versions of table. So version 1, version 2, version 3, version 4. So now we are in version 4. So this version 4, which all are the, like we saw, we had around 7 Parquet file. So which all file will make the current version. So that information will be there in this JSON. So let's try to view the data from the JSON file. So I will use SQL here. Select star from JSON dot, and I will copy this path with the file name. So when I try to view it, so we will be able to see few columns like add, commit info, and remove. So what this add is, so this add is nothing but, so it will have the information like which all are the Parquet file it want to recognize for the current version, for the version 4. So this add will have the files which the current version is using, and what this remove is the Parquet files which are being omitted for the current version. So Databricks won't go and delete the files whenever you make a transaction, like insert, delete. So it won't go and make changes in the same file. Instead, it will create separate files, and it will capture all the transaction log in this JSON file. So that's what we are seeing here. So how to see the version of the table? So we have the student table, and we made multiple transaction there. Like we inserted, we deleted, then we made a few updates, and we also made an merge operation. So so in order to see the versions of the table, we want to say describe history, then the table name. So this will give all the versions of the current table. So if you see, we have totally 4 versions, and we will be also able to see like who made these operations, and when these operations, like we will also have the timestamp. Then we will also able to see what type of operation has been made in that table, and what all are the operation parameters. So we will be able to see all these information using this describe history students. So now what we are going to do is, we are going to view the version 1. We are not going to roll back. Instead, we are just going to preview the data from version 1. So how we can do that is, we can say select star from students version as of 1. So even we can use the version, or we can use the timestamp. So we can use either of the things. So I'm using version. So when I say version as of 1, it will preview the data from that particular version. So this is what the current, initially when we inserted records into the table. So this is that version. So we were able to see those two classes which has 11, and the 101, 102, and 103 records. So now what we are going to do is, let's say we accidentally deleted delete the table. So delete from students. So what I did is, I deleted deleted all the records from the tables. Let's verify it whether the records got deleted or not. So let's start from students. Yeah, so we can see there is no record in the table. So now how we can do the rollback to the latest version. So we know the latest version we had is 4. So in order to do a rollback, we want to say restore, sorry, so restore table name, restore table students, restore table students to version as of 4. So 4 was the latest version and we want the 4. So when I execute it, so it will roll back to that latest version. Um, so even we will be able to using select star from student version as of, using this we will be able to preview the data, and if we want to actually go and implement if we want that particular version's data into the table, then we want to say restore table to version as of and whatever version we want. So we want fourth version, and you can see so it restored 4149 bytes of data in, and also it restored the 4 records which were present in the table, and it has restored it successfully. So now let's try to view the data from the table. So now we were able to see all those records from the table. So we have successfully restored the table to the older version. So now let's see what it is showing in the uh, transaction history. So describe history students. So when I execute a describe history students, so the fact that we have deleted and restored it, so we cannot hide it from this Delta Lake tables. So we will be able to see all these transaction whatever we have made in the Delta table. Also, we will have those versions as well. So even that deleted has version 5. Even we can see that data. So whatever we make, all those transactions will be captured and it will create a separate version for those. Now let's do one thing. Let's try to drop the table and see whether we were able to see those Parquet files in that location. Okay, so drop table students. Yeah, so we have just dropped the table. I will go back and try to get that. Yep, so this is what I wanted. So we'll create a new cell. Okay, so now what we will do is, we had this folder called students and we had around 7 to 8 Parquet files. So now let's see, when after dropping the table, whether this folder actually exists or not. So when I execute this, it's saying it couldn't find any folder like students. So let me just go back once and we'll make sure there is no such folder. So here you can see we have the students one that we created earlier just for testing purpose, but we couldn't see the students folder here. So that means when we drop the table, everything will be the Parquet files and everything will be get dropped as well, will be get deleted. So there is no way where we can go and restore it once we drop. So when we delete, we will be able to roll back to the version, but when we drop it, the entire file and the folders will be get deleted. So if you have any questions, please post a comment and I'm happy to help on that. So thank you for watching.